All right, number three. Number three is a question that it's show me you don't know physics without you telling me that you don't know physics. All right, because if any physics teacher see this two words coming together, mass and pounds together, it's gonna drive them nuts because pounds is not a mass, it's a weight. And that's why I said earlier, your teacher lumped the mass and weights together in the same category, which I can understand. And let's just roll with this. Now, a common question that we have is this. What number do we start off? There are two numbers right here, 1.2 and 55. What number do we start? Now, so let's go ahead and look at our analysis. It's a density. How many dimensions are here? Two. It's mass and volume. Look at this. How many dimensions do we have? Just one. It's a volume, right? And we are asking for the mass or weight, and that's also one single dimension. So if your answer is asking for one dimension, then you should start with one dimension. That's how you can tell what to start. Okay? And then we say, hey, so what's the route? How can we convert this? Well, this is a density with mass and volume, right? Now we got a volume in gallons, but not in cubic centimeters. So can we apply this density right now? We say, no. You got to convert the volume to the same unit as described in the density, and then you can go ahead and use the density number. So that means we got to change to gallons too. Well, what do we know about the conversions at the top of the page? Well, 1 gallon is to 3.79 liters. So we're going to go to liters, and 1 liter is to 1,000 milliliters, and that's why earlier I told you about the equivalence between milliliters and cubic centimeters for this reason. They're the same. And this is where you can change your dimension from volume to mass right here. All right, because the density has a gram in here, but gram would then be converted to pounds. So again, you should map out all these conversions before. Okay? You should map out all these conversions before you start. So now we say, all right, let's go ahead, get to work. Now, here's another thing why I do not like to use the railroad track that your teacher is doing. So your teacher is likely going to do this. And I have one genuine question to ask. How long should I draw the line? Now, I mean, you can say, well, just draw whatever. But actually, there is a psychological impact. Because if you don't know how many steps you're doing, well, you really want to question how long you should draw the line. If you draw the line too short, you think it's going to be this small amount of steps. But if you draw it way too long and it actually requires a small amount of steps, you have a psychological pressure to think like, did I do something wrong? Because I thought it's going to be more, but I'm only writing a few. So that's why I would go for something more neutral. That's why I just write down fractions. 1 gallon is to 3.79 liters. So now I know how many liters there are. Okay? Now, actually, what I just said, it's very crucial that your ability to state that, oh yeah, I know how many liters they are, that it's very, very crucial. Because that explains the purpose of this step. And then we say, hey, go ahead, change to milliliters. If you don't write units, you are sacrificing a whole lot without a good reason. So we did all these things just to convert to a cubic centimeter. And then now it's a moment to shine, because now we can go ahead and apply our density. So now we finally have a change in dimension. So before the purple fraction, it was all just within the dimension of volume with a different unit. But now we're changing the topic to mass. And then we want to change to pounds, right? So 454 grams is to 1 pound. So that's how we convert. Okay, that's how we convert. $55 times 3.79 times 1,000 times 1.2 and divide by 454. So I've got 551 pounds. Okay, 551 pounds. On my calculator, it says 550.9. So since we only need 3 sig figs, and both of these two numbers are of 3 significant figures, so we have 551 as our final answer. Good? Any question? No? So again, if your answer ends with 1 dimension, then you shall start your calculation with a single dimension. Okay, if not, it's likely going to be something more complicated.